Hello, Professor Takar. I'm Shariza Fekni. Welcome to my presentation on recurrent neural network, RNNs. And these are the topics to be discussed. Recurrent network are a type of neural network specifically designed to process sequences of data. Unlike traditional neural networks, RNNs have connections that form directed cycles, enabling them to maintain a memory of previous inputs. This makes them particularly useful for tasks where the order of data matters, such as time series forecasting, natural language processing, and speech recognition. The types of data in RNNs are time series that is indexed by time, such as stock prices, weather data, or sensor readings. Text data for sentences or sequences for words, useful in tasks like language modeling, sentiment analysis, or translation, and sequential event data to clickstream data, medical records, or any data where events happen in a specific order. The widely used libraries for RNNs are TenorFlow and Keras, as both provide high-level APIs for building RNNs, including popular variations like long short-term memory and gated recurrent. PyTorch is another popular deep learning library that offers flexibility in designing and training RNNs. The purpose of the convolutional net layer are typically associated with convolutional neural networks, CNNs, and are used to detect local patterns in data. When used in conjunction with RNNs, they can extract spatial features from data such as images or segments of audio before passing these features to the RNN for sequential processing. The pooling layers are used to downsample the output of convolutional layers, reducing the spatial dimensions and making the model more computationally efficient. The types are the max pooling and average pooling. The architecture of a recurrent neural network is designed to mimic certain aspects of biological neural networks, particularly the way the brain processes sequences of information. In an RNN, each neuron in the hidden layer has connections not only to the next layer, but also back in itself. This creates a loop, allowing the neurons to remember information from the previous time step. The biological behavior is similar to how neurons in the brain can fire in response to a current stimulus, while also being influenced by previous stimuli, creating a memory or context of influences decision-making. A reward example of RNN implementation is the language translation, which is one of the most common applications of RNNs in a machine translation, such as Google Translate. In this scenario, an RNN processes a sequence of words in one language and converts them into another. The RNN's hidden state allow it to remember the context of the sentence, ensuring that the translation is accurate and maintains the intended meaning. Another real-world example is in speech recognition or Siri and Google Assistants, which are primary examples of how RNNs are implemented in real-world application to convert speech to text and recognize patterns in spoken language over time. These virtual assistants rely on RNNs to process and understand the continuous stream of audio input, identifying words and phrases to generate accurate text translation. The challenges in training of recurrent neural networks are due to their complex architecture and sequential nature of the day-to-day process. The two major challenges are vanishing, exploding gradient, and vanishing and exploding gradients. The vanishing gradients become very small, hindering learning. An example, in the long sequences in languages, modeling can cause this issue. The other is the exploding gradient problem that grow exponentially, causing instability. An example is training on long time series data can lead to this problem. To mitigate the challenges of training RNNs, such as exploding and vanishing gradients, two key techniques are commonly employed, which are gradient clipping, used to prevent exploding gradients by capping their values during the backpropagation process. The other is the long short-term memory, designed to address the vanishing gradient problem by incorporating memory cells and gating mechanism. These memory cells can maintain information over long sequences, and the gating mechanism control the flow of information, deciding what to keep, forget, or output at each time. This is the summary, and these are the reference. Thank you.